Hey guys, hi, how we doing? So I'm gone today. That's why we're having a class via computer. That's why technology is super great that we can still do things when we're not around physically. So today's kind of a goofy lesson, and we obviously love goofy lessons. Today we're going to either look at a table or a graph and decide if it's linear, quadratic, or exponential. Remember, just a quick recap. Linear is just a line. Quadratic is what we've been doing lately, is parabola. And exponential, remember, it would increase really fast or it would decrease really fast, right? I think that was from about 2 chapters ago. And it's not too hard once you get the hang of it, but these lessons are always kind of goofy because it kind of, they're just not a typical math lesson. They're just odd, I guess. So let's just first get a little summary here of linear, quadratic, and exponential. So linear, remember, is a line, and here's our favorite form, y equals mx plus b. And a way to tell is obviously our line just going up at a constant value, right? Rise over run is the exact same no matter where you are. Okay, our next one is quadratic, and that's what we've been dealing with as of late. Here is our standard form, y equals ax squared plus bx plus c. And then it tells us the difference of the difference. That's kind of weird. So your second difference in values is constant. We'll talk about that in a second, okay? So the difference of the difference is constant. That's kind of weird. Okay? And then our last one here is exponential. Okay, we did that a couple of chapters ago, like I said. Our generic formula is y equals a times b to the power of x. Remember, your exponent, your variable is in the exponent, that's why it's exponential. And then it says our y values have a common ratio. Okay, again, I don't really like using words in math because I think until you see it in the numbers or an example, it's like, what does this mean? It's so confusing. So if you're confused right now, don't be. We'll figure it out. We always do. Our first set of examples are just plotting points and then looking at the graph and determining what it is, okay? So if I go too fast, pause the video, plot these 4 points, and come back with me and make sure you just plot them right. Not a big deal. If you can multitask, you are awesome. You guys always know that you're so awesome. Okay, so I'm starting right here. 0, 1. Put the point. 1, 2, 2, 4, and 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so it's looking something like this. So now remember, we only have 3 options. I'll put them up here. Either linear, quad, or exponential, right? So obviously there's always one that we can easily throw off the table. Clearly this isn't a line, right? This is not increasing at a steady rate. That's a duh kind of thing. But now it's like, well, I only have part of my graph, so is this potentially a parabola? I just don't know the missing parts, right? Is it like this? Or is it potentially like this, exponential? How are we going to figure that out? I only know 4 points. Well, this is where those kind of goofy little blurbs of information is. So let's check to see if it's quadratic. So it says the difference of the difference is constant. Well, what does that mean? Well, I'll show you. Draw a little quick T-chart for my kids. X, Y. And all you're doing is plugging in your x value or your points. So we had 0, we got out a 1. 1, 2. 2, 4, 3, 8. Okay, I just grabbed that stuff from our points up here. Okay, now I'm just finding the difference. That means how far away is from 1 to 2? It's 1 away. How far is 2 to 4? 2 away. And how far is it from 4 to 8? 4 away. Nice work. Okay, so here's my first difference. That doesn't really tell me much. I need to check my difference of my difference. That means AKA my second difference. So check how far away it is from 1 to 2. That's 1 away. And from 2 to 4 is 2. So if I go back up here to my little blurb, it says the difference of the difference, so that's your second difference, in the y values is constant. Well, if I look, is this constant? Are 1 and 2 the same number? I hope you're thinking, no, they're not. So that just ruled out that it's not quadratic. So therefore this one is exponential. Good job, guys. So this one would look like this if we were to finish it out. It's kind of a hard one to start with. Don't get bent out of shape. They're not all like that. Okay? Now let's try B. Okay? So again, just plot your points and let's see what we can figure out. So negative 2, 5, 1, 2, 3, 4, 5, 1, 7, 1, 2, 3, 4, 5, 6, 7, 0, 9, and 1, 11. Hey kids, I hope you're noticing up 1 or up 2 over 1. Up 2 over 1, up 2 over 1. So this would be our favorite linear. It's a line. That was pretty obvious. All right, turn the page for me, guys. Now number C, or letter C. Negative 1, 2, 0, 0, 1, 2. Well, right now your brain should already be thinking quadratic because I'm going down and coming back up, and my other two forms, 1, 2, 3, 4, 5, 6, 7, aren't allowed to switch direction like that. So by just common sense, we already know this one is quadratic. Good deal. So that is just identifying what kind of either what kind of model you have, linear, quadratic, or exponential, using points on a graph. Now it says, let's figure out if we're just given the table. If you're a visual person, grab some scratch paper and just plot these points. If you really can't figure it out, it's not the end of the world, but there's always a quicker way. So there's a lot of words on here. I'm just going to try to abbreviate it or sum it up in the fastest way possible. So this first example here is a linear model. And I think it makes the most sense because look, they're always going to usually go by ones in your x column. Do you guys see that? I choose a different color here. I'm just increasing by 1, and that's what they're saying here. And then if I go to my right side, my y values, what's happening? What's my difference, right? How much am I increasing by? Well, you guys see from 1 to 2 is plus 3. From 2 to 5, I'm adding 3 more. 5 to 8, another 3. 8 to 11, another 3. So do you guys see how we got the same thing? The whole time it's going up constantly. Think, that's a line. It's constant. So the y values have a common difference. That's your key there. They go up at a constant rate. Okay? Now if we bump over here to our exponential model, again, kind of boring. Your x values are just increasing by 1. Cool, super great. We know that. Now I'm going to bump over to my y side. So I've got to think, how am I getting from 0.25 to 0.5? So in your brain, you can be thinking, well, you're adding 0.25. Okay, that's fine. And then if I come over here, from 0.5 to 1, I'm adding 0.5. And if I'm going from 1 to 2, I'm adding 1. And if I'm going from 2 to 4, I'm adding 2. Whoa, like that's crazy. What's going on there? Well, you just kind of have to look at this. Every situation is going to be different, but you just got to use like your thinking cap. What do I notice about now these values right here and here? Well, I know that 0.5 is 2 times as big as 0.25, and I know 1 is twice as big as 0.5, and I know 2 is twice as big as 1. So really, guys, to simplify that, all we did was multiply by 2 each time. Okay? So that told us it's an exponential model. So the y values are, we're going to go like this, are multiplied by the same number. So times 2, times 2, times 2, right? So that's how you can tell it's an exponential model. Now for quadratics, this was the difference of the difference. So this is where you have to check the first difference and then check the difference of that. So that's kind of what we did in that first example on the front. So again, your y values are just increasing by plus 1. And then over here, check your first difference. So from 1 to negative 1, I'm subtracting 2. And then from 1 to positive 1, I'm adding 2. And then from 1 to 7, I'm adding 6. And then from 7 to 17, I'm adding 10. So now, an easy way to check, like, how am I going to be able to tell quadratics from exponential? Is there any number I can multiply 2 by, negative 2 by to get to 2? Well, sure, I'm multiplying by negative 2. But if I take now positive 2 times negative 2, do I end up at 6? No, you get negative 4. So that's how that already cancels out multiplying by the same number. So now that's when you check to see if the second difference is the same. So how far is it from negative 2 to positive 2? Well, it's 4. How far away is 2 to 6? Well, it's another 4. And lastly, how far is it from 6 to 10? It's another 4. So again, did we see our second difference is the same? Yes, we did. So the key there is the second difference is the same. It's constant. Okay? I know I just talked a lot without a lot of example. I think we just need to go in there ourselves and try it out, all right? So turn your page and let's see if we can figure these out. So it says, which type of function best models the data in the table? Use the difference or the ratio. So again, just make sure so they're not like trying to pull a fast one on you that your x's are going up by 1. By 1, by 1, by 1, by 1, plus 1. Now we're going to pop over to the y side and let's just see what's happening. So this is increasing by 0.25. Then from here is plus 0.75. And then from 1 to 2.25 is plus 1.25. And then from here, I'm increasing by what? 1.75. So let's think of the obvious. Are these the same number? Am I increasing by the same number? No. Therefore, not linear, right? I'm not increasing by the same number. Now I gotta think, is there a number I can multiply by 0.25 to get to 0.75? Yeah, times 3, right? But if I take 0.75 times 3, do I get 1.75? No. Therefore, it is not what? It's not exponential. I'm not multiplying by the same number either. So now lastly, you check the second difference. So I'm going to erase these. So how far is it from 0.25 to 0.75? Well, it's 0.5. How far is it from 0.75 to 1.25? Oh, another 0.5. And 1.25 to 1.75? Look at that, another 0.5. So if our second difference is constant, which one is it? It is quadratic. So do you guys see that? How your second difference was 0.5, 0.5, 0.5. Therefore, it's quadratic. Okay? I think that one's the hardest to notice just because you have to do a two-step thing. Okay, let's check out B. Let's just make sure. Going up by 1, by 1, by 1, by 1. We check out there. Good. Now let's check out what's going on with our y values. Plus 4. Negative 2 to 2 is plus 4. So far, so good. 2 plus 4 gives me 6. That one works out. How far is 6 from 10? Plus 4. Yay, an easy one. If I'm going up by the same amount each time, that's just a line. I'm going up by the same amount. It's linear. Just a straight up line. Good job, guys. I mean, I'm assuming we can probably all guess what C is, but let's just check it out to make sure we know that we're right. Again, going up by 1, by 1, by 1, by 1. Now let's check out our y values. Going up by 0.5, going up by 1, going up by 2, and going up by 4. So again, how can we figure this out? Well, how much greater is 0.5, or how much greater is 1 than 0.5? Well, it's 2 times as big. How many times greater is 2 than 1? It's twice as big. And how many times greater is 4 by 2? Well, it's twice as big. And same thing here, how many times greater is 8 by 4? Well, it's twice as big. So I'm multiplying by the same number, which we said would be exponential. So if we multiply by the same number to get to each thing, it is exponential, right? Times 2, times 2, times 2. Thank you guys for watching. If you are so confused, talk to someone in our class. We're a pretty bright group. I bet you hopefully someone has an idea. Remember, teamwork makes the dream work. If we're stuck, help each other out. I will fix any issues when I see you guys in class next, okay? Have a good day.